Have you ever looked at an app and wondered, how does it think? Well, today we're going to pull back the curtain and see how we can give code a brain. We're going to explore how a simple script can transform into software that actually reacts, makes choices, and decides what to do all by itself.
So let's just start with a quick thought experiment. What if an app could only follow one single straight list of instructions? Just do this, then this, with zero ability to make a choice or repeat a step. It would be super rigid and, let's be honest, pretty useless, right? Well, that's exactly what we call the straight line problem in coding.
The solution to this problem is a concept called control flow. I like to think of it as the director of a play, telling the code which lines to read and when. It is the absolute magic that lets a program break free from that boring top-to-bottom path and become something truly dynamic and, well, intelligent. And here's the really cool part. All of this seemingly complex logic, it's all built from just two fundamental superpowers. That's it, just two. The power to make decisions and the power to repeat actions. If you can get a handle on these two things, you can seriously build almost anything you can imagine. All right, let's dive into that first superpower, making choices. This is where we teach our code how to look at a situation, evaluate it, and then decide which way to go, kind of like we do 100 times a day. Okay, so the most basic tool for this is the good old if-else statement. It's really just a fork in the road for your code. The program asks a simple yes or no question. If the answer is yes, like, say, your age is 18 or over, it goes down one path. If the answer is no, it takes the else path. It's just a simple two-way choice, but man, is it powerful.
But what happens when you need more than just two options? Well, that's where something called the else-if ladder comes into play. Think of it like the code is literally climbing a ladder, checking each step as it goes. First, it asks, are the marks 90 or higher? If yes, boom, you get an A, and it stops right there. If not, it moves down to the next step. Okay, are they 75 or higher? And it just keeps going down that ladder until it finds a condition that's true, or it hits the very bottom.
Now, that ladder technique totally works, but it can get a little clunky and hard to read if you're just checking one single thing against a whole bunch of possible values. For a situation like that, there's a much cleaner tool for the job, the switch statement. So here's the deal with switch. The program takes one single input, like a number representing the day of the week. But instead of climbing a ladder one step at a time, it's more like an elevator. It instantly switches and jumps directly to the right floor, or, in this case, the matching case. So if the input is 3, zap, it goes straight to Wednesday. And if it can't find a match for the input, it just goes to the default option. It's way more efficient and direct.
Okay, so our code can now make choices. That's one superpower down. Let's move on to number 2, the incredible power of repetition. This is the one that saves us from having to write the same exact line of code 1,000 times.
We harness this power using things called loops, and the idea behind them is actually really simple, but it's also profound. You just write a block of code one time, and then you tell the computer, hey, run this thing over and over and over again until I tell you to stop. This is, without a doubt, the engine that drives all automation in software.
So when you know exactly how many times you need to do something, the for loop is going to be your best friend. It is built for precision. You just give it a starting point, an ending point, and you tell it how to count along the way. It's just like telling a robot, take exactly 5 steps forward. No more, no less. It's perfectly predictable.
But what if you don't know the exact number of times you need to repeat something? That's where while loops come in. And there's a really key difference between the two main kinds. You've got your standard while loop, which is pretty cautious. It checks the condition before it even thinks about running the code, so it might not run at all. Then you have the do while loop. This one's a bit bolder. It runs the code first, at least once, and then it checks the condition to see if it should go again. That's the key. It guarantees the action happens at least one time. Okay, now this is where things get really, really powerful. Making decisions is great. Repeating actions is great. But when you start combining them, when you start nesting them inside of each other, that's when you can create some truly sophisticated and amazing logic.
And a perfect example of this is a nested loop. It's exactly what it sounds like. You just put one loop inside of another loop. This kind of structure is fantastic for anything involving grids or tables, or, like we're about to see right now, for creating some really cool patterns.
All right, check this out. Imagine we have a big outer loop that's going to run 3 times.
On its very first trip around, it tells a smaller inner loop to get to work. And for this first lap, that inner loop only runs one time, printing out a single star. Okay, now the outer loop starts its second lap. This time around, it tells that inner loop, hey, I need you to run twice. And there you have it, 2 stars on the next line. You can already see the pattern starting to take shape, right?
And finally, on the third and final lap of that outer loop, the inner loop runs 3 times, and that completes our little triangle pattern. Just like that. By combining 2 super simple loops, we created a predictable structure. And this very idea is the foundation for so many complex algorithms out there.
So I know this might all seem a little abstract, like we're just talking about theory. But the truth is, you interact with this kind of logic constantly. So let's connect the dots to the real world and see control flow in action inside the apps you probably use every single day.
Just think about it for a second. When you're at an ATM, it's using something like a switch statement to handle whether you want to withdraw or deposit. Or a login screen. That uses a for loop to give you, maybe 3 tries before it locks you out? Even a simple calculator uses a switch to figure out if it should add, subtract, or multiply. This logic, it's literally everywhere.
Let's actually break down that ATM logic a bit more. The entire time you're using it, you're inside one giant loop that just keeps running until you finally hit exit. When you choose an option, a switch statement jumps into action to direct the program. Then, if you choose to withdraw cash, an if-else statement has to check your balance first. It's a perfect real-world example of how all these simple little building blocks work together to create an experience we all know. So after all that, from the simplest choices to those nested patterns to the complex apps we use every day, it all comes down to this one number. 2. That's it. Just 2 core superpowers. The power to choose a path and the power to repeat an action. So, we've basically given our code the fundamental building blocks of a brain. It can follow logic, it can make choices, it can repeat tasks, it can learn in a way. So the only real question left is, what are we going to teach it to do next?